All right, where are we at here? We are working on learning Linux, right? This is entry level beginners Linux stuff, and we're going to do some more of the Socratic method. We haven't done that in a while, so we'll work on this and we'll talk about learning Linux and how you can ask yourself questions and see how much you know. We'll work together as a little group here for people that want to ask these questions and answer them for themselves. So that's where we're at. All right, so the first ones we'll be doing are CPU topics. So some of you have been here before, but what do you know about the CPU in your system? What do you know about kind of what's going on in your system? So the first one is, can you list the number of CPUs you have in the system? Do you know how to find the number of CPUs that you have? What are some of the commands that'll do that for us? Where are the places that we could check in a system to know how many CPUs it's using? What do you guys got? What do you guys think? A few low-hanging ones. There's a few that take. Let's see. MP stat. That'll tell us some information. I think you might have to do an MP stat with like a -p all, -l all. What am I thinking here? Huh. Maybe it's -t all. There we go. And that'll show that this box just has the two processors. That might be good. I thought it was maybe it was -a all. There you go. There's P. Capital P all. That's it. There we go. nproc's a good one. I like nproc. How about cat proc CPU info? Would that show us all of them? Yeah, but you got to manually count them up. So I tend to do this. And then if I don't want to count them. So that'll do it. How's it going, Sanako and Zorgol and yeah, Colkiss, everybody that's kind of hanging out. We're just working on talking through like things that we can answer about a system, things that we might ask ourselves questions, and then can we figure out how to do the different things. So the first one was, can you list the number of CPUs? And I think we can. I think we can do nproc. I think we could do probably any of these other ones that kind of got us to the same general answer of, two processors, right? And there's different varying amount of information that you might see with the different ones. Top might even give you an answer. Nah, top won't really do exactly that, but that's fine. All right, so we can list the number of CPUs. How about this one? Can you tell me the speed in megahertz of those CPUs? So if I had four servers, and those four servers, I wanted to make sure that they had the same exact CPUs in them, same speed, same number. How might I go about checking that? Linux developer said nproc. I'm a big fan of nproc. That one works. Yep, nproc works for the other one. But what do we do to tell the speed in megahertz of the system? What are some ways to do that? What do you guys know? I think LS CPU also will give you some of this information as well. Will that give us our speed? There we go. There's our speed in megahertz right there. So LS CPU will do it. What if I told you that cat proc CPU info will also give you it? There's your CPU megahertz right there. What other ones do you guys know? Cat proc CPU. Yeah, you would find it there. That's exactly right. How about dmessage? Would dmessage show it to us? Dmessage shows us the speed that the system detects too. So that's a good one. What other ones? What might DMI decode give us that? What's in DMI decode? Let's see if there's a whole bunch of stuff in here. There's a lot of information to look at on your system. And I may be able to see. Yeah, there's the speed of our system right there, 2400 megahertz or 2.4 gigahertz if we cared. Okay, so that's gonna maybe inform us to know some, information about the type of processor that we're dealing with. What if we needed to know? What about if we need to know the manufacturer of the chip? We needed to know that not only are these the same systems, again, you guys are going to get in systems and they're going to be poorly documented from the get-go. You're not going to know, nobody's going to have talked about, nobody's going to have written stuff down for many years sometimes, and the Linux guy before you was spending so much time putting fires out, he never documented anything either. So now you just sit down and the manager just puts his hand on the shoulder and he's like, all right, get to it. And you're like, do we have any documentation? And he's like, and he just walks out of the room because that's all he knows. He literally, you, as soon as you log into the first system, already know more than he does, right? About the system. So this is a problem, right? This is the kind of thing we don't want in the systems world. So sometimes we have to go figure out what's the manufacturer of these chips. So how might we tell the manufacturer of the chip? Did any of these other commands give it to us? Maybe we knew that it was Intel, so we just guessed Intel. And we can just throw that grep for a search function on the end of everything that we're doing. So we have all the ability right here to just touch everything and see all the parts of the system. So can we tell the manufacturer? Yeah. Are there more of those? Sure. DMID code should be able to help you out. LSCPU dmessage probably has Intel in there. For sure, there's the information about our processor. All right. Something that might be useful. Do not flip this switch post-it note. Yeah. Or do not erase this disk and it's put by a magnet onto the wall. Yeah. Excuse me. Can you tell me the architecture of this chip? Is it an x86, x86 64? Is it an ARM? What type of processor are we dealing with? Are we dealing with a 32-bit or 64-bit architecture? What might be able to tell us that? Are there any hints in the system that aren't directly related? Are there any hints in the system that aren't necessarily directly related to the processor, but can tell us about the type of things that are going on in the system? Arch, is that a command? There you go. I've literally never used that command before. There you go. How about this? Uname-m will give it to you. Uname-a will give you too much info, but uname-m will give you the good info. What other ones might help us? Cat, proc, CPU, info, grep for maybe 86. That might not do it. How about architecture doesn't help us there. We go just look at the data, see if there's any things in here that might alert us to the fact that we're on a 64-bit system. Yeah, nothing going on in here. Unless we see the x86 64, which I don't see anywhere. But you might go look up the type of chip and realize that that type of chip is x86 64, and that would do it for you. That would be a good start. Uname-r is one of my favorites. Arch is a good one. I did not know Arch. I had never used that command before. But anything that can dump that in there for you. And then you can have a simple check. You can have a simple check in your code. Maybe you're writing some script or something, and you've got some if, backtick arch is equal EQ x86 64. You do something like this. Then, so if then you say echo, this is a 64-bit system, and then phi, right? And then, did I not do that right? No, equals is fine. We do equals there, right? Because it was looking for a string, and it doesn't matter. And then we could say, we can say else. Echo, this is not, this script cannot be run here. and maybe we throw that to a log or something, right? And then we know that that's good, and then we could have done something like it. Well, let's just change that, and then now it'll say the wrong info because we don't have that exactly. However, we could have done something like this. Is it equals tilde? Something like that. No, tilde. I always get this one mixed up. It's I thought it was equals tilde, but it's it'll do it if it's like in the string. But that's fine. We don't really care that much. All right, so the point is you can go and you can mess with that stuff. So can you tell the architecture? Yeah, we know that it's the architecture. So can you tell me if this system is physical or virtual? Can you guys do that? Can you get in there and do the virtual nature of this system? How would I know that this box that I'm on is physical or virtual? I mean, short of looking at some documentation, I've dropped into this box that's up. Oh. Oh, I got it. All right. That's fine. So can we tell if the system is physical or virtual? Can we do that? It's because it's greater. Yeah. Oh, I need to do that the other way, didn't I? Yeah, you guys got to remember, I don't do a whole lot of bash scripting anymore. But that's, yeah, no, you're right. So I would have had to flip those and then say, yeah. Would that work? Guess we could test it. Is the system physical or virtual? Yeah, x86 isn't. Yeah. You're right. I haven't done this in a while, so I have to go this one backwards, but with the tilde before, right? Tilde's still before. I can never remember if it's tilde equals. I used to do Perl and can never remember. Nope. Backwards. I always do it backwards, guys. There we go. An arch. Arch. What if I gotta like do something with that? Anyways, I don't know. I always get that mixed up. Vert what is great. Yep. All right, vert what, if you have it, is great, but you don't always have the command. Yeah, it could be that too. I could have been messing that up. It's been a while for me on this specific one. There we go. So the script cannot be run here because it's not found in Arch. Yeah, I always get those mixed up. I swear I'm doing that backwards though. But anyways, doesn't matter. Vert what is great, but it's not always there. What else do we got? Yep. And what we could say is DNF what provides vert what, and see like where it's at, if we need to get it there. So it's just a vert what command. DNF install vert what. There we go. Also, I gotta let you guys know we've got the Linux groups still running this weekend. We're in week 2 of the courses. So there's the Linux sysadmin course and the security engineering course. Those are both free. Go hang out and do all that kind of stuff, right? So we've got that now. Vert what will tell us we are virtualized. What if I told you we could also do DMI decode, grep-i vert, and maybe Zen, and we would see the Zen information. What about uname-a that would also tell us? That might not tell us if we're virtualized, though. What about DMI decode? We also, well, there's some hints. LSmod, grep-i for, let's just say you just look through LSmod. There's some hints that you're dealing with virtualization in here because you have the virtualized, where are they at? Where's some of the virtualized, like the virtualized NIC? And if you know to look for them, you'll see those. But I wouldn't rely on this one. I'm just saying this is one that might help you out. But I'm a big fan of VertWhat. VertWho will tell you where it's at in a system, which is actually one that Red Hat uses so that they can charge you more. If you've got your VMs on separate processors you don't have the licensing for, they'll charge you more. Where the hell is that? Why don't I see it? It doesn't matter. You can probably DMI decode grep hypervisor. No, you don't see hypervisor there. But in dmessage, you should see that you are starting. Yeah, the system is in hypervisor. There you go. Yep. So it's a Zen hypervisor. Yeah, that's good. Yeah, Hayes, I've been working all day, man. I'm kind of beat. So, thanks for the follows, guys. Hopefully this stuff's useful to you. We're just we're doing our little Socratic lesson on Linux. We kind of mess around with this every now and then. I have, I don't know, a few hundred questions that'll pop up over here, and we can just look for, do we understand the system? Do we know how to get answers? How about this one? Can we spin the CPU up to a high load for 3 minutes? Do we know how to do that? Well, we've got stress, if stress exists. And we could say stress-c, maybe 2 for this box, and then -t 180, and maybe I background that. And then maybe while it's backgrounded, I say while true, do uptime, sleep to done. And we just sit here and we watch that system spin up on the CPU right there. So that 1 minute first CPU value is going to go kind of high as the system is stressing in the background all of those, stressing the processor, right? And then we were messing around with this yesterday and we could see how many threads were going against how many CPUs, and we were having fun with that. And we were talking about like whether or not somebody's actually processing like they think on a system, and how we can go and look at it. Alpha Victor Charlie, how do I post a copy of some of my Linux notes in the Discord, as in file in chat or GitHub gifts? You should be able to, Alpha Victor Charlie, anywhere that you can post, you should be able to drop those. I have a meeting notes channel. I'm pretty sure you can post in there. If not, you can always drop things in. There's like a bash systems and tricks channel, which we have a lot of channels in our Discord, but I think our Discord in the big scheme of things is not too difficult for anybody that's not been in there. You hop in here, you've got mostly like the tech stuff up here. You've got general chat stuff here. Then you've got off-topic stuff, which you can close that. Like for people that don't like that stuff, just close off, don't see that. Then there's resources for like beginners, all the things that can hopefully get you guys going in the chat. And then we've got events, right? There's always events coming up. Also, I haven't told you guys much about this on stream, but we always do an annual like virtual conference. We started it last year, so last year was our inaugural one, and this year will be our second annual, right? Because inaugural and then second annual. We do a big annual just virtual conference. So we'll do it on August 9th and August 10th this year. I have a bunch of guest speakers coming. I already have me, one of my brothers that's in data analytics, my good friend Jared, who does Google Analytics, and he does quite a bit of website stuff with a pretty big company, do over $1 billion a year in website sales. So he's does a lot of that. He's their main Google's analytics guy. We're gonna have a economist come in that I know, and a cybersecurity red teamer for the military. He's gonna come in and talk with you guys as well. So I have a whole bunch of things to come down, or a whole bunch of people to come down and talk with you guys this time. And those are always free. We typically do 4 talks a day, and then you can just hang out and get in there. So yeah, so you guys are able to be in there. I know my talk, some of you guys have seen my talk before. It's called Why Engineering, and I'm going to keep updating it. I've got more stuff to add to it. So this will be like the round 2 of it. My brother Tommy comes and he just pulls data analytics off of sites and shows you guys how to like do stuff for real. So he does some pretty good stuff. James Lynch, how's it going over on the YouTube side? Clear skies today. Yeah, I know the East Coast. Well, I work for NOAA, so I know the East Coast was getting hammered, And then we're quite cool in Phoenix. We're only 67 right now in the middle of the day. We're supposed to be 102 by the end of, I think by the start of next week. So Phoenix is like roller coastering it. But I know on the East Coast, there were 430 weather tornado warnings last night from NOAA. I know that number because, again, I work for them. But there were warnings all last night. So anyways, come to the Linux admin course if you want. Come to the security course if you want. Those are on Saturday. We've got the writer's room, which got moved. So that's on a Sunday now. That's there. And then there's the conferences that's coming up. These conferences fill up too. I mean, we had 100 people plus the last time in each event. And this year with so many more people, I wouldn't be surprised if we start getting near our cap of 500, which would be pretty cool if we can get that many people. I'm always trying to break Discord. We've managed to break Discord before, so it'd be fun to break Discord and see what some of the limits are. So, anyways, we saw the system go to a higher load. We see the system now drop off of that. That stress process is no longer running. Stress is no longer running, so we're good. It's cleared. We spun up the load on the system. So maybe we needed to do that for some reason, and we need to use a tool like stress. That's a great tool. We could also do it. There's other ways to do it. There's we can DD, and then we can pull in bigger files and then compress them and throw them away. So we could do like DD. In file is like dev urandom, and then like out file is equal something like we could actually just do dev urandom, and then block size is equal 1024K. Count is equal like 5,000, so it's like a 5 gig file. And we're going to take that, right, and we're going to throw it through like a bzip -9, which is the highest level of bzip, and then we're going to throw it in dev null. So we're going to toss it out, right? And one of these might not do too bad to the system, so I might time this. Right, and throw it in the background. Oops, we don't have bzip. Maybe we need to use. Oops. Maybe we need to use gzip. Right, and then that's going to be backgrounded, and then that'll be done. All right, we can go see that that's still running, and hopefully when that's done, it'll give us the timeout, and then we could not the timeout, but the time that it took to come out, and then we'll know how long it took to do a 5 gig file. But while that's running, you'll see that the load average will start to go up on the system as it's doing that work. That load average is going to go up. And if it didn't go up, then we could just make a bunch of them. We could just spawn a whole bunch of them, right? Let's go look at the jobs. It's still running. So let's make this a little more obvious, because that's not using that much. Let's go back up to here. Let's wrap this in a for I in, and then do like a sequence of 10. So we'll do 10 of them, then we'll do it. And you might say, Scott, at the bottom there, you should add a semicolon. Well, no, not if I want to ampersand and background them all. I can do it all in one shot like this. So this is going to make 10 of these all at once. And now watch my system's uptime. So I can just bang while, and it'll be my old while command. And watch the system shoot up in CPU load. Right here. We might have crashed it. No, we didn't crash it, but it definitely took longer than 2 seconds to come back there. You completed your first ticket today, Hayes? Were you working on something? What were you doing? Check voltages. I missed some stuff. 77 in your city at 90% humidity. Oh, that sounds all right, but it gets a little warmer. That would be brutal. That would be a little brutal. That's pretty high. Yeah, I got fans running. I got a little fan on me over here too. But all in all, I'm doing all right. Okay, look at that system spinning up all that load, and we'll know when it's done with all of those, because that'll start to drop off right there in the 1 minute time. And we looked at that yesterday a little bit, right? Today we're just asking ourselves questions, right? We're doing systems admin work where we we use a thing called the Socratic Method, and we just ask ourselves questions, right? And so here's our next question is, can you tell me how much RAM we have? Can you prove for yourself, if you went to a set of servers, how much RAM they have? And if that's too easy, can you do it against a list of servers? Yeah, James, I'm doing okay. I'm a contractor to NOAA. I don't work directly for them, but I've watched a fair number of people in other programs go away. My program wasn't hit hard because I'm on what's called NCEP, which is environmental prediction. I think it's National Centers for Environmental Prediction. So we do all the stuff that predicts the next 10 days worth of that. Well, I run all the high performance compute that does that. So that's kind of a thing that I work on and I do. So. Yeah, Hayes, that's the problem. People are always going to wait until there's a problem to tell you about it. And then they're going to be like, well, he slowed us all down. And you're like, yeah, you could have told me this 3 weeks ago if you'd tested. But then people never do anything. Yeah, these things happen. So how much RAM do we have? Let's let this thing stop climbing, and then we'll go from there. Let's see if any one of them has finished yet. Nope, they're still all running. Let's see. We'll wait until it drops under like 8, because when it drops under 8, it's going to be coming down for real. Oh, hey, it's okay. Yeah, there's a lot of there's a lot of that hurry up and wait in IT. I think I told you guys I was sitting in a meeting. We were doing this thing a few years back, and it was all like trying to get all this automation worked into everything. And I wrote all my stuff while I was sitting in one of the meetings. Sitting there working, and this guy Brian Wisely was sitting over my shoulder, and we got it all working. And I raised my hand. And I said, "Hey, I'm done with my part." And they go, "Okay." I sit in that meeting every morning for like weeks and weeks, and like about like probably like 5 weeks later, they say, "Hey Scott, is your part ready?" And I'm like, "My part's been ready. I could literally push the button whenever you wanted." That's been true for 5 weeks. But teams do things different. Everybody does things different. But that's one of the things, I had already deployed mine, multiple times and tested it. And I was ready. Actually, I had it building every day in a set of test systems, which is what I normally do. And then when it's ready, I just cut it over to the live systems. Very minimal things to work out if you can build something every day, right? So, all right. So can we tell how much RAM we have? Well, this box is pretty hammered, but how much RAM do we have? Free-M will do it. Cat proc mem info will help do it, but that's very raw, right? That's very raw. How about free-MT? It'll give you the totals at the bottom. That's kind of nice. What about, Hayes, did you get to learn what were you using for your pipeline? Were you using Jenkins or some kind of code builder, or what was your pipeline tool? Some people use Terraform. There's all kinds of ways to kick off pipelines, but I guess GitHub Actions is a big one now too. I think our guys are using that to build the, some of you guys that are working on building the books right here. These books, by the way, the books are not completely done. They're still under a little bit. The guys are still working on them a little bit, but they have a lot of content in them. They have at least the first. I told Treasure really the goal is just to be 1 week ahead. So we're going into week 2. So hopefully week 2 is pretty done, and you guys can get. Well, it's getting there. Oh no, maybe it's. I thought these ones were all done. Well, hopefully they're ready by. If not, I guess we're doing it live. Oh wow, I thought all these were done. Am I looking at an old version of this? What's going on here? All right, hold on, I gotta stop. Oh, this is a security course. You guys gotta stop me, man. All right, no, we're going into week 2 this week. Yeah. So we're gonna be doing systems administration. We're doing stuff that we've been talking about this week, but we're gonna be doing it over on the course over there. So, all right, that'll be good for you guys to get in there. Also, yeah, I think we're doing some security SE Linux on this one. So we hit some of the stuff pretty early on for this week. Yeah, here we go. Those are the things that are going on this week. The stuff for this week on the security course, I can't show you here. I could show it if we had it here. It's securing the network connection and integrating network in a secure fashion. So we'll be doing that. Where'd Ranger go? Ranger's left us stuff. All right, how much RAM do we have? Free-M, meminfo. You might be able to get away with dmessage, grep-i RAM. That may be too much information though. But does it give us just a raw amount of RAM? Nah. Nothing here that I would say is super useful there. Probably a little too much information. Yeah, I wouldn't trust any of that. Anybody got any other good ones? Any other good ways? Alpha Victor Charlie said we were showing you how to do Grafana a while ago. Yeah. Did you know if you want to build Grafana out too, so if you want to build your own little Grafana stuff, you can also come to Killer Coda. And in Killer Coda, I have some labs on Linux. You've probably seen this, but I'm going to show anybody else. I have a few labs that are on monitoring. So these 3 labs on monitoring. I'll just link the Linux labs and you guys can go find them. Cool thing about Killer Coda labs for people that are kind of newer, they're free. They don't cost you nothing. You just go and use them. LSHW-C memory. LS show might not be installed on a system, but let's see if we can install it and then get that to work. Let me think. The main thing about any of your monitoring tools, I think, is just knowing where your ingest is coming from, where you're storing things, and what's the process of getting data out of a system over there to the storage, and then how are we monitoring it, presenting it. Let me see. Let's see. The memory. Does it give us all the memory? One thing I didn't show you guys today that I kind of constantly hark on, especially in the group, is... Yeah, there we go. Yeah. I always tell you guys, make sure you have a notepad open. Like, if you're doing this stuff... Yeah, Alpha Victor Charlie, what happens if you've never been in SSH, if you've never been in one of these, you drop right into the shell right here in your command, right in your browser. So you're SSH right here. It's one of my favorite things because it just literally drops you in a shell right here. Sometimes I do the labs and then just have you guys follow along with me, and we just run through and install everything and do whatever. But yeah, you're in a command line right there. Yeah, so you can, there you go. Here's your Killer Coda instances. Install all your stuff. And then, I gotta get all these sudos out. I don't like the sudos in here. Don't need to be sudo if you're already root. Build all that, run, get Grafana, and then get it running on the system, right? Okay, so how much RAM do we have? I think we hammered that pretty good. How can you tell how much RAM we've used? Is there a way to figure out like how much RAM is used on a server? How much RAM is... What's going on in the system? What's the way we do that? How would we know? Let's get out of there. How would we know how much RAM we've used on the server? That can show us how much we have free, how much we have cached. How about our normal free-M? Free-M will do it. Except the rest. So, VMstat will show you how much you have free. Your free-M will show you how much is used and how much is free, so that's kind of nice. I'm a big fan of that. Some people like the T on there because then it gives you the totals at the bottom. We're not using swap because our whole system is already in there. Yeah, I think VM one of my favorite. Also, by the way, if you were saying, hey, Scott, is that system, is it still in the background using high load? Yeah, see all these waiting right here? These are all the things that are waiting, requesting time against the processor. So even though we did VMstat, we can still see that our system is bogged down right now. We can see that the system's still in the background doing those jobs that we have running. Could we kill them all? Sure. Do we need to? No. I mean, if you guys want to see how to kill them, there's a few ways. You could probably just call the jobs forward. But what I do, if I wanted to kill all these, I would do a ps dash maybe ef and grep for maybe dd, right? And here would be all my dd commands right there. And I would probably skip those ones. So I might do grep dd and then grep urandom, right? Now that would strip them out. So now that would only be the ones that we wanted. And I would say, okay, that's cool. And then what I would do maybe is run that through a awk for just the second column, which is the process ID right there. And then xargs will put it all on one line, and kill -9 would kill them all. So there they go. They were going to run forever, but they finished. And then now if I do jobs, and if I do uptime, if I bang while, we'll see the system slowly drain out on how much CPU is being used. That's CPU though, by the way. This is just CPU here though, but I just wanted to show you guys that that was something that was still plaguing our system. So, all right, so VMstat, great tool. Free-m or free-mt. The cat proc meminfo will give you the raw information that you want about how much memory we have and how much is free. It's true, but it's a little hard to read for most people. But that is the raw memory in the system that's available. So 1.5 gigs or so. Yep, that's what's free. Here's the total, about 4 gigs, give or take. Right. Free needs a dash beer option. All right. How much RAM do we have used? Yeah, we can see that on the system. These are all tasks that you might run into. Can you tell me how much swap we have left? Well, how much swap do we have? We're not running any swap on our system. Free-m also shows that there's no swap. So we can see how much swap's on our system. How about this? Can you free, if you got all this cached memory over here, can you free all of the cached memory? Do you guys know how to wipe or commit to memory all the cached memory? There's 2 different commands that we do. But how do we free all of the cached memory in the system? By the way, it's not too late to get involved with those Linux engineering courses, the sysadmin or the security engineering course. They're running free in Discord. You guys are welcome to hang out there. My main reason for even getting online is to show you guys that you guys can do this stuff professionally. That would free all the memory, just like when the Meeseeks decide to take 2 strokes off of Jerry's golf game, when they take all the strokes off of Jerry's golf game as they kill him. That was their eventual plan to get out of their thing. But can you free all of the cache memory? Yeah. We could try sync. We used to always do 3 of them. But that might not do it, because maybe that buffer cache memory really is doing something. If you're in a database server, almost all the memory that's being used and cached is truly being used. So you really don't want to do this on a database server. But sync might do it. But there's one. You can echo 3 into proc sys vm drop caches. If you do this, then you do your free-m. Oh, it should have done it. We should have seen that it had wiped the buffer cache. I think the reason it doesn't do it on these systems, because this has happened to me before, I think the reason it doesn't do it on these is because we're using tempfs. And in our tempfs, I think it keeps that cache and you can't wipe it. But normally I can wipe buffer caches on systems. Let's see. Over here, I think we got our Moodle. Look at that giant, massive buffer cache that this system has. It doesn't have a lot of memory free, so I can just say echo 3 proc sys VM drop caches. And now when I do a free -m, watch this, it's going to have wiped all those. Yeah, see how the buffer cache is almost nothing now? Because it wiped them all. It's going to slowly build back up, but it should be fine for now. So why 3? That's a good question. There are 2 other values you can do, and I forget, but like 1 is only uncommitted, 2 I think is like committed only, and 3 is all of them. So I don't remember the exact, but you can do you could do the other ones too, but this one is the more final one. So if we go to like, go ask the Googles, and we say proc sys VM drop caches values, it'll tell us the other values, right? So to free page cache is echo 1, to free reclaimable slab is 2, but then to just free everything is 3. There it is. So hopefully that's a good answer for you guys. That's the answer. You can find that. I'm sure you can find that in the man pages too. But those are the ones. I never use 1 or 2. I just jump to 3 typically. Because here's the thing. If I'm ever wiping that on a production system, the team has already killed their processes. We've already gotten rid of the process. Now we're trying to wipe the cache so that we can bring it back up almost universally. So I would never do this unless another team that I was supporting was already involved, because this is already like going nuclear on it, if that makes sense. But I did see over the years Java would leave their processes open and would not clean up nice. So then I would come in here, they would kill their processes. I would do the echo 3, wipe everything, get the cache back clear, and then they could start their app back up. So it's a way to do things. Can you free all the cache memory? Generate high load for 3 minutes. We won't do that for memory. We were doing that yesterday. But let's do some file system topics. Can you show all of the space, all of the used space in the root partition? How do you show all the space that's used on the system that you're on? What do you guys do? I just need to know, somebody tells me the system's not working, I can't make a file. What might you go check? df-th gives you the type in there too, huh? I'm very used to df-h, but that th is nice because then it shows you the type. Can I show you the one you guys would never want to use? df-h is great. df-h, df-th. Can I show you the one that I'd probably never use? df by itself. That's very unworkable. I mean, the percentages are still good, and you could see in a quick glance how the percentages are done. But yeah, I do like that type column too. I might start using that. I hadn't used that before. That is nice because then you very quickly see that we've got NFS version 4. We could have mounted some things NFS version 3 for testing, and somebody forgot to move it back to NFS version 4 for like a, when we're starting to do, we're probably still down in the dev environment, but we're starting to load up for like prod testing before things go to, and maybe we find that somebody left one of the NFS versions on an older system. That would be a great thing to find out with, a command like that. So I'm just thinking through the way that I would want to look at these things, right? So can you show all the use space in the root of the file system? Yes. Now we can also see everything else. We can also be very, very verbose by doing the exact argument and only showing the one thing. So that's good. Depends how close we want to be on this. Yeah. So can you show all of the inode usage? You do a df-th like that, and you see that the system's not full, but a user still can't write a file. Is there a reason for that? And I'm going to tell you guys that I've seen inodes fill up twice in my career. Both times they were on a file system called GPFS. I've never seen them fill up on normal systems or under normal conditions, but in big high performance compute environments, I've seen it happen. We have so many, millions of small files sometimes. That's there. Oh, I'm getting asked questions about propagating users and Werewolf. I might have to go help people out with that. But how would we find the number of inodes? Could we just add an I to this? Would that show us inodes instead of the normal info? Yes. And then could we see how much usage we have of those inodes? So there were 487,000 inodes. We've used 87,000 of them, and we have 400,000 free. So could we? I think we're gonna have a question coming up here for us, right? These are like our own. The Socratic method is to ask yourself questions and to think through things, right? So can I show all the inodes? Yes. A question that might come up from this is, what the heck's an inode? An inode is a memory pointer, right? It's a location. Sorry, it points to a memory location, right? When you run out of inodes, you can't address any more memory. So if you had real memory left over, but you ran out of inodes, you can still not write one more file to the file system. Can't write a single extra one. Even though you got all this space out there, you have no ability to address it. Therefore, you can't put it out there because you'd never be able to retrieve it. Inodes are tied to a file system. Inodes are used up by hard links. And inodes are the primary reason, when you learn about them, that we cannot have a hard link across file system boundaries, right? File systems that are within one partition are their own map. So I couldn't be in my library and have an address to like your library somewhere else and tell somebody to go over there. That wouldn't make any sense. You can do that with a soft link. Soft links can do that all day. But hard links actually generate an inode, and you can't use that for cross. And I've shown that to you guys before, but we could do it here. We could just make something like, so we've got, in that's PWD. We're in root. Touch some file, right? And then I'll try to link right now. I'll try to link some file over to like labs test file, or let's say some file over there. And say, I can't do that, buddy. But could I soft link that over? Oh, it's read only, so I can't do that. But let's try it again. So in lab work, right? Failed, still failed. And then we'll try the -s, and it won't fail. And then if I just echo, this is my stuff, right, into some file, and then I cat some file, and I cat lab work some file. Well, too many levels of symbolic links, but that's something else that we could go dig into if we had a problem with that, right? But the point is, we can just unlink it and get rid of it. But the point is, you could do that. All right, where are we at here? Can you show all of the used space in the current directory you're in? So I'm in the root of the file system. I know how to find, we did DF earlier. We know how to find all of the usage of the partition we're on, right? Right, the file system we're in. But can you show me how much is being used in this directory that I'm in? du-sh, really good. So let's make a 1 gig file and prove it to ourselves. So we're in here, dd in file equals dev 0, out file equals big file. We could do root big file if we want to be exact. Block size is equal to 1024K, and count is equal to 1000. Now if we do that and we do our du-sh, it should be 1 gig bigger because we just added a gig. And then if we were to, so df-h would show us that it's 37, right? It's more used. But if I were to go over to like temp and do a df-h on, the root, and then I did a du-sh on this directory, there's nothing in it. And the dot is the argument if you don't give an argument, right? That's what's used. So we can look at the all the space in the current directory we're in. We can see that we used it up, and then we can just rm-rf big file, and then it's gone, right? Sometimes I like to be verbose and say dot. Same thing with df-h dot. Like where I'm at, where am I at? Like what's the file system that I'm in? Because things can be mounted in different ways around your system. I think somebody showed me that before. Was that you that showed me that, Kithro? ncdu-r. I think this was a command. ncdu. Let's see. There you go. Yeah, you can see what's going on. What's going on in our Ansible directory. All right. That's kind of good. Yeah, read only. That's nice because then it doesn't change anything. Somebody showed me that a long time ago, that ncdu, and I mean, shoot, I've probably forgotten more Linux over the years than anything, but yeah, so we can, but there's a lot of ways to do it, guys, and I would just tell you, find one that resonates with you, find the tools, like know how to use the tools now, guys. That's why we do these type of exercises, so that if I ever have to figure out how used or what is using all the directories, I can do it. DUF. I don't know what that is. Let's see. Don't have that either. Might have to be one I have to install. I don't know, Synthal, I don't know, or Sithal, I don't know about the DUF. Is that DU-F and then dash only local network? I'm not sure. Okay, so can you show all the space? Yeah, and this is like, we're just asking ourselves questions. We're just walking through this stuff. Can you show me, this is a fun one. We're in root, we see this. Can you show me all the processes that are using the current directory you're in? Do you know that command? I actually built a lab for this command recently. This specific command recently. I put this command up in, I did a whole lab on this one for people. Joey Bites, that might do it. Let's see. I'm not sure if this one will work. That'll find all the root users. I don't know if it'll show me /root. There's a command that'll do this for you. It's a nice command that'll succinctly look at the directory and look at every process that's touching it. Super useful for a lot of things. Yep. So lsof and then just root in this case. Right? The directory I want to hit. Now lsof-p is great for a different reason. Let's say I knew my process. If I needed to do lsof on the process 10910 to see all the files that this process that I'm using is holding open, that's what that would be really good for. So lsof, and then one of my other favorites is lsof-i on port 22. Here's all the things that are touching port 22. Shutdown -r now does fix a lot of problems. Doesn't fix the staying employed problem, but it does fix most of the other ones. That's true. Yeah. So lsof is great. With no argument, it should just give, I don't even know what it does with no argument. I'm going to say LSOF here, and there's just the things in root. LSOF may just be all open files otherwise, but you can give the process ID, right, and see what my bash process here is using. Here's all the libraries that my bash is touching. Here's all the things that it's holding open and doing right here. Very useful for certain things. Alpha Victor Charlie said, where am I getting my questions from? They're all right up here, top right. This is a thing that I wrote up years ago, a couple years ago now. And it's what we call the Socratic Method. We just ask ourselves questions. We're in right now file systems. So Fuser might work. I don't know if I ever used that one though. Let's just try root. I don't know what I'm, oh, user. Wonder if, here, I'll just use that. Well, I mean, that does show my bash. Yeah, that's, I mean, shows that. You can also do like a PS tree. I don't really use this command much, but there's a way to use like against just that one. And then, you know, if I knew the parent ID of my process, which I can find out right here. So here's my bash. Here's his parent, right? So then we can see, and then if we, well, so then we can check his parent, right? And then there's the 1016. Uh, 906, that's what it is. So there's that. There's also a way to see that in like a more dash A. Yeah, so, you know, something like that. So you can like go through those. Yeah, so you have a lot of stuff that you can kind of mess with. For me, LSOF is really excellent. And here's why I would use LSOF, right? Let's say that I was on this box, I did df-h, and some of my users were reporting that this lab system was having a problem. And I go, oh, well, I'm a Linux admin. I'm root. I can go on there and I can just do a umount, you know. But if I do a umount on labs, let's make a problem real quick. If I go to umount labs and somebody's sitting there in labs, it's busy. Is there a way around it? There is a way around it. The way around it, though, there's a thing about this command right here. The lazy unmount seems like when you first learn about it, you're like, that's awesome. I just chop stuff up. I pull any fucking file system down, bring the system back up. There's weird things that happen in a system when you just unmount file systems and you've got processes dangling out there. If you had systems that were trying to write to this, now they have to time out. If you have users that were using it and their bash was in there, they're going to be kind of floating off in the wayland until they figure out how to CD back to where they're at. You'll cause problems. You'll cause massive instabilities, and you will probably, I'm just going to tell you this, in big systems, you will probably never remount that on this system without a reboot. Not 100% true, but without massive amounts of cleanup and stopping things that are reaching in there and all this other stuff, if it's a production system, you will, if you do a umount-l, you'll accomplish your mission of closing down. If it's time to decommission something, sure, get rid of it. But I'm just telling you, if you're doing it on like a live system when users are using it, you will probably have to take that system down to get that file system back. That's just one of these things in life that's not great, but it's true. So it's not optimal, but it's true. So don't just use umount-l willy-nilly. In old Solaris and Unix style systems, it was umount-f, but we don't use that anymore really. Umount-l. But anyways, so can you do that? Can you unmount things? Sure. So this one's fun. Check the long listing. What is a long listing? Check the long listing. If you don't know what a long listing is, you got to figure that out. Like, we know how to LS things, but what's a long listing? What's a long LS? Yeah, you'll get weird. So James, I used to deal with a lot of zombie processes in high performance compute systems back in the day. It almost always had to deal with big SAN and then disks not being available. Well, to be fair, a UMount-A would be okay if all the production systems had something in them. But yeah, don't do that. Yeah, don't. There's a scene. I need to get it. This is like real dark humor. So hopefully this doesn't offend anybody any more than anything else. But there's a Rick and Morty episode where the dinosaurs come back, and there's a guy that this is bad. So there's a guy who comes to the dinosaurs, and dinosaurs have all the answers, and they're like trying to make society better. And this person goes to him and goes, what if you have like a, what if you just want to like kill yourself? And the dinosaurs look at him and they're like, what? Well, don't do that. That's kind of how I feel with like the shutting down the system. Well, just don't do that. That's bad. Hey, it's it's a dark Rick and Morty joke. All right. Oh, also, I see I need to fix something here. Let me go to my low. Let me see if I can hide. I gotta check something. See if I can turn something off here. That's probably fine. That's probably... Screw it. Alright, let's do that. Alright. You guys see that better? I think you guys can probably see that better now. Yeah, there you go. I got that little taskbar off the bottom. Alright, so, can you check all these? What's an LS? What's a long listing? Okay. So we long list with -L. So if we do an ls-ld, we'll get a long listing of root temp. You can actually do that on etc shadow, etc passwd, etc ssh sshd_config. And do you know what all of those little letters there mean? This is kind of a thing to think about for a second for some of you. Can you think through what those mean? I'm gonna take a... Where's my streaming thing here? Camera. Boom. I'm gonna do a little hourglass and say, think about all right, take a break. I'm gonna walk it out a little bit. You guys think through the question on the right there. Why do we need to know those? What are those access control lists? What do those things mean over there? All right, I'll be back. Grab me some more water. Take a little walk. I'll be back, guys. can't stand my water bottle up. It keeps falling over. All right. I'm back. You guys thought about this a little bit? Okay. Pull all this back up. You guys are still on break if you want it. Still on break. That's true that there's a dot on here. That dot might mean something. More modern Linux systems have that dot. So, how would we, if we needed to, how would we explain these permissions? Well, there's a couple of commands that change these permissions. Well, we're still on break. We're still on break. So while we're on break, feel free to let me know if you guys have any questions about anything. If you guys want to know about that course or you want to know what we're doing this weekend, I think my wife's out of town. No, not this weekend. I think next weekend my wife's out of town. So I'll be on most of the time. I'll be working too, but I'll also be on quite a bit because when the wife goes out of town, I just hang out and play on the computer. So yeah, so chmod, chown, chgroup, change group for sure. Those are all effective ways of changing these. So if I wanted to read about it, by the way, this will be a fun one for some people as a slight bit of a challenge to you. Could you do all of what I just did in one command? I just showed those all to us, but could you do in one command could you list all of those out in one command? Or in one press of the enter key, I guess. Another way that might be challenging would be if you were on one system, could you do, so could you make sure that they're the same against a bunch of systems? Oh, Kafka's down. Well, I knew Kafka was down. But could I make sure that these are all the same? Sure. Are there other commands that can do that and maybe be a little more efficient? Sure. There's a pdish command that can aggregate those all up, and that might have been nice to use, but this is fine for now. What about this, though? How might I show all of these in one command? It would probably be a loop, right? It would probably be for, I guess item in, and then a list, do ls-ld item, done. But where do I get the list from? Anybody know? I think I get to this later in here, but how do we generate that list? I can think of a few ways to generate a list, but let's do it the simplest way, which is we'll just put the items in list. I've used DRDB. If you're thinking about disaster, like DRDB, is that what you're talking about, or is it DRBD? Maybe I'm thinking of this backwards. I was thinking DRDB. Maybe I'm wrong. Oh, it is DRBD. Okay, well, I definitely had that backwards in my head then. Yeah, I've done this before though. I used to run this on. Who still runs this right now? HPCM runs this still, so HPCM is a really big, by HPE, it's a big thing. You might be able to put them all in one path. But what if you didn't know all the paths, Darth Vader? What if you were going to pull them out of a file? Could you do that? WinStore. Yeah, DRBD. For some reason, it was DRDB in my head. I haven't used it in a while. But HPCM definitely uses that for some of their back end. Who else is using that? But that's like replication at the disk level between the systems. And it's worked pretty good that I've seen. Works fine. I've seen databases use it underneath like DRB, or what's it called? What's the name of that tool? HPCM uses it. So yeah. Been a while. All right, where are we at here? Central Linux tools. That's what we're doing this week. Central tools and probably some SE links. I kind of tried to work in the admin course, even though we had to touch all these things. I tried to touch a lot of security and automation throughout all of it. So we're gonna hit all that stuff in there tomorrow. Not tomorrow. Saturday. You could give it all the paths. I'm just saying maybe you wanted to pull these in. I would think of a better way to pull these in. I would actually put these into a file and then read it out of the file. That would be a good way to do it. Cat some file, right? And then it would drop them all in there too. There's a bunch of different ways to do this, I would say. And also that's my older way with the backticks. Some people like this now. And by the way, does anybody know why I switched to that method when I write stuff in the labs? So if you guys do any of my labs on Killer Coda, I no longer do all backticks like I used to. I used to always do backticks in Linux. I grew up with them. They've always worked for me. That's always the way I've done things. Does anybody know why I switched off of backticks and started doing this? Or in the labs, you'll see this everywhere. I'll do that. Anybody know why? I do this because Markdown language is already using backticks, and I just don't want to deal with escaping in Markdown. So I just use the other thing. Yeah. Oh, so yeah, that would be if we had put them all in a file, right? But anyways, the point is there's a lot of ways to do it, guys. But do we know what these permissions are? Do we know what's going on with this one? So this is /root, which happens to be the root of the home directory of the root user. That's what /root is. You can also guarantee that by saying grep root from etc pass wd, and if the root user's in there, the 6th field should be his home directory. So there you go. There's him. Operator also has root. That's not good. That's not good. He shouldn't be able to be in there. But now the root owner over here is this file right here. So these two names right here mean something. And if nobody's ever shown them to you, maybe it'll help out a little bit to know that this is the user owner of the file right here. This is the user owner. And this is the group owner of the file here. Now all of these happen to be root. So I might have something like ls-ld on home. I think there's an S Champagne. If there's not, there's definitely a Scott too. There we go. So the owner, the user owner is Scott 2, and the group owner is Scott 2 as well. All right. So we come back up here. We look at this real quick. The root file system has a 7 permission right here. So it's a 4, a 2, and a 1, or a read, a write, and execute. It's called octal because when you have 000 through 111, you can have the numbers 0 through 7. So if this is the 4's column, this is the 2's column, and this is the 1's column, then that means this is a 4, 2, and a 1, so this is a 7 in this field. And that 7 right there, read, write, execute, are the permissions that belong to the root owner, the user owner of the file system, or the file, whatever it is. The second field right here, which is read, no write, and execute, so it's a 4, nothing, 1, 5. That's a 5, is for the group owners of the file. Meaning, with a file system, that they can read and traverse the file system. Those are the two things that happen there. This one is also 5, but who is this one for? It's not for the user owner and it's not for the group owner. It's for everyone else. So everyone else that could possibly ever touch this file system doesn't need to be defined. We've defined the group, the user owner and the group owner. So everyone else just falls into this last category right here. So that's how that works. Everybody. I like it. All right. So then, temp has similar things. By the way, if it's a directory, it's going to have a D here. If it has just a dash, it's a file. If it has an L, it's a symbolic link, right? The peasantry. Yeah, everybody else that's not root. Temp has read, write, execute, read, write, execute, read, write, and a T. And that T means something else. And then there's a dot. So let's real quick. Let's see if we could go to chmod, man on chmod, and see if we could find out what the file systems mean. So we can go down and look, and we can see that we can set these letters for the bits of the affected users. And it says that T is the sticky bit. So if we were to have that T in there being shown, that's the sticky bit, right? And then UGO permissions granted. Okay, so you can go look at these different things. There's the numeric modes of the values that can be set. And then they've got the set UID and set GID bits. These are important to know about how a file system is going to behave when you set them, right? If you set the UID and the GID bits of a file system, when things are written in there, they will be owned by the user owner and the group owner, right? There's things that you can set. So there's restriction and deletion, and then they talk about that a little bit. We can come down here and we can see how this command would work. So there's some things to kind of look at there if you want to get into that. But again, you can look at these permissions. It's a good idea to be able to look through this real quick and go, that is a 644, and the implications of that, without anything else, the implications. Anybody know where the implications were, and what was the implications of getting on the boat with Mac and Dennis? Well, the implication. All right, anyway, 644. The implication of this is anybody can read this file if they can traverse to it. If they can traverse to a directory that has this file in it, they can read it. That's what a 644 means. And who? Root, and everybody else in all the world. The implication. Well, surely you would be in no danger. He tells the woman that there's this older woman looking at him like, it's a great scene. All right. So, can you remount the temp directory as read-only? Do we have temp on its own? If we don't have temp on its own, we're going to have a little bit of problem there. Uh-oh, somebody's here. Guys, I will be right back. I think my wife's laptop's getting delivered. I'll be right back. 1 second. 1 second. I'll be right back. I'm here. Coming. Guys, did this just become an unboxing stream? Oh man. Hold on a second, guys. I'll wait for the laptops here. I feel like this just became an unboxing stream. Hold on. I'm just kidding, I don't have it set up for unboxing, but wife's laptop. My knife that just happens to be open because I was putting together her desk earlier. All right. You guys probably can't see that. It's just a laptop. There's nothing special about it. You guys don't want to see that. To tech Tanis. All right, let's see what's going on over here. Oh, yeah. Look at that. You guys probably can't see that, but Welcome to Dell. So I just got her a little Dell laptop that she wanted. Because she is going to run some things for me. It's actually funny, Dell throws a lot of work at my company. Not that I got like a discount or anything, but Dell's definitely paid for that laptop many times over. Paying my company to do work. So we get a lot of work thrown at us from Dell in general because Dell focuses on the hardware and the support, but there's a lot of things that are very specialized inside of the high performance compute world that my company and me specifically does. Security of systems, some of that stuff. I think it's just, I have a G15, so I have a gaming laptop with 64 gigs of RAM. Hers is, I think it's just a little, I don't know. I don't know what this thing is. I'll bust it out here in a little bit. Oh no! Just lost my fan off my desk, guys. I've lost my fan off my desk. Poor fan has been knocked over. I got it back. All right. So I have a Dell G15. I don't know if, no, it's a Dell one, but it's got just a Core i7 in mine. I bought mine a while back when I first started streaming, and I was having a lot of hard times. My other laptop was dying. Threadripper Pro. No, she didn't want anything special. She got like a, I mean, that box is probably, it's like a $1,300 little laptop, and then there were some discounts on it. So I think we got it like 800 something. You know, it's all markup, and it's like cars, you know, cost them 12 cents to make them, but then they, you know, get them out the door for whatever. All right, it's not that bad. All right, so we can't remount the, well, we can't mount it on here. Well, we kind of could, I guess, but we don't have. All right, well, let's just do it real quick. So, could I remount the temp directory as read only? And yeah, I guess I could, because I have right here fdisk -L grep-I for XVD. I've got these extra disks, so let's just mess with one. Let's just say makefs.ext4 on dev xvde. That's fine. What? All right, we're gonna delete the partitions. We'll do an fdisk on dev xvde, and we'll go ahead and say, oh, he's got all kinds of messed up things. So let's just say p, and then let's go ahead and he's part of a Linux raid because we were doing labs in here with these last time we ran the group. So let's wipe it real quick. Real quick, we'll go 1. So N1, we'll do primary, make it primary partition 1. First sector, he can be the whole disk. We'll do P to C, that he's the whole size of the file system, and then we'll write him out, right? So writing, and then now we're gonna go ahead and take that box, and we're just gonna make on XVD1. What? Maybe I gotta fix the label. I might have to fdisk with the wipe on it. What? Oh. Wipe always. go ahead and D, and then we'll do a new one, P1, whole size, write it out, good, and then alright, well, fuck, I don't know how to wipe that. I guess I could just DD and wipe the thing for good and just start over. But XVDE, right? And then block size equals 6K and count equals 1. What what was it? XV? You guys gotta stop me sometimes. Out file. My bad. There we go. And that should be enough to wipe it, but we could do 256 if we really wanted to. Shouldn't matter, but it should wipe that disk. Huh. You just want to wipe. Who's calling me? Hold on real quick. The Scott. Pretty good. Hey, but I'm in the middle of something, dude. I can't talk right now. Alright, bye. That's annoying. Alright. Package got delivered. Everything's good. Okay. Why is this thing not... I should just be able to wipe this disk. Oh, why that's not wiping? Why is that such a... Oh, that is the full side. Okay. I might have to... Anyways, what I was going to do was make a file system and just mount temp on there. It doesn't really matter if we do it or not. Yeah, these are all just lab boxes, so I don't care what happened to them. I should just been able to F-disk wipe those. I haven't wiped a system in a while, I guess, so I guess that's not that big of a deal, but parted would have done it too. But anyways, could we mount, just mount dash, or just mount the temp directory as read only, give it the -O option for RO, and it would be read only. You can also find that in the etcfs tab, instead of defaults, you could just make something read only, right? We're gonna wait for that node to come back up. All right. So, can you list the number of free inodes in slash? I think you guys can do that. df-i, we did that. Can you make a file and then have 3 hard links to that file? I'll let that run for a second. Just go to one of the other boxes. So we touch test file, ls-l test file, and we see that it has one hard link to that, one hard link to that. Now we're going to make 3 hard links to it and verify each time. So ln test file to test file 2. Now there's 2. ln test file 3. Now there's 3. test file 4. Now there's 4. So if you ever wondered what that number was right there, that number is the number of inodes that point to a memory location, right? That's a number of hard links into a file. So if I echo, this is my test file, into test file, right? Whoops. Help if I did that right. Right? And then if I cat test file 3, what do you guys think is going to happen? Do you think it's going to be an empty file, or is it going to be going and looking at the same memory location as all the other ones that are linked over there? Doesn't matter which one I cat, it's going to be the one. So, knowing that, what happens if I remove the original test file? So let's ls-l on test file everything. There they all are with 4 hard links each. I'm going to remove the original file. What does that do to the others? Are they gone forever? This is actually an important behavior to understand in how Linux actually deletes things. If I delete the original link, so I'm going to unlink, RM is really just unlinking the inode pointer to it. If I delete this, is it going to go away? Are the other ones still going to exist? Are they just going to be down to 3? And are they still going to work? Or am I deleting the original data and not, like, that's an important question. Does Linux delete data from a file system? Does it actually ever delete data? Not unless you tell it to specifically, right? Look at all of them. They only lost that one. And if I cat test file 2, it still has the data in it. And then I can link test file 2 back to test file. The system doesn't care. We're now back to all 4 of my links in there. Again, hard links though like this, where we actually add inode pointers to the file system, do not expand. They don't go across. You can't span file systems with them. And that's the crux of the matter, Alpha Victor Charlie. If I delete all 4 of these right now, the data, like we can no longer access it from Linux. It's floating off into space, but the data is still resident on disk until it gets overwritten by something, which is a very important forensic thing to understand. If you just go in and just delete all your data and you're like, they're never going to get me. No, your data is still sitting on those disks until it's been written over. In fact, I've seen processes that can get data back off of disk after 30 writes. So there's tools out there they'll do block writes. They'll do like 8 ones and then 8 zeros and 8 ones and 8 zeros across the board, and then they'll do 7 ones and 7 zeros and they'll just stripe across the disk over and over and over again to wipe disks. And there's a whole bunch of there's like a partition tool. I forget its name, but there's like a couple hundred different standards out there from around the world. Yeah, Alpha Victor Charlie. That's very important to know in the Linux world, is you can still get data back after it's been deleted. It's just special tools and some forensics. So, John Carter said, "Do I own my company?" I don't own my the company I work for, Redline. No, I don't own them, but I do enjoy working for Redline. They're a really good company. But no, I don't own them. I also don't own NOAA. That's a government project. NOAA. I guess I own the Prolug, which is the Professional Linux Users Group. But that's just me running the ship, keeping everybody on track. But no, I don't own any businesses. I try to stay out of doing business stuff. I try to just hang out and do fun stuff if I can. All right. So could we make all those links? Yep. Can we hard link to a file across file system boundaries? Even if you reformat a drive, you only delete the partition table at the front. All the data's still on it until it's overwritten. And good tools can still get it back. All right. Back to this. We can't hard link, right? That's not necessarily a trick question. That's just think about it. Think of how hard link works. You're addressing a memory location on a different file system. That doesn't make any sense. If you came to my library and opened up and looked at the thing and it said, yeah, the book's right here. You just go across town to the other library. You'd be like, F you. I ain't doing that. I'll read the book here. I'll go read a different book. All right, so anyways, that's how that goes. Can you cat out the file that defines the mount points in the system? It's the etcfs tab that defines the mount points in the system. It's honestly, the etcfs tab is kind of a dying file. And does anybody know why? Does anybody know what's supplanting it in the Linux world? There's a way to do files now that are totally different. I don't dislike it. It's just a different way, right? What's this other way that's kind of coming out? Not coming out. It's been around for a while. But they're systemd mount points, right? Have you guys seen these? And down in here, there might actually be some in here. Do I have it? No. In some of these, you actually you define nowadays that's not one. Normally they're just named by the mount. Doesn't seem like this system's doing it, but in modern Linux systems, the etcfs tab just gets slurped up with a system daemon reload, and it just makes mount points as part of systemd. So systemd mounts are kind of the more modern way to do a lot of this. You get more timing control where, everything can start up and then it kicks off than you used to with just etcfs tab. Etcfs tab is a holdover from our old RC init way of doing things in the system. So files deleted, inodes are deleted, that's why files are re-recovered. The file names cannot be recovered. I'm not 100% sure for that, Alpha Victor Charlie. I've never dealt with that. Yeah, for when you delete a file in Linux, you are definitely only deleting the inode. The system information is still sitting out there. Yeah, if you have a big database or something, you delete your inode pointer to it. That database is still sitting out there until something writes over it. Yes. Yeah. So that's probably, that I don't know if that's why file names can't be recovered, but that's what you're deleting is the pointer to that information. Yep. The information itself still exists though. Yep. Can you cat out the files where that's cat etcfs tab, right? Here's how our system has defined where everything's being mounted from. All right. Can you test the read and write speed of your file system? Now, it's kind of tricky in this system because this system isn't writing to disk anywhere. I erase the file, save it, and then delete. Mr. Couture, I'm not sure what you're asking me, but if you erase a file, it's no longer known by the Linux system. And then you're saying you save it through some method, like you go out and you read the data and then you figure out what it was and then you pull it back and then you delete it. I mean, you're just doing the same thing again. That's not that's not how it works. Okay, but let's let's do a write and read speed of our system. So how might we write speed to the system? We have two ways. I like that T. We have two types of file systems maybe. So let's write to the home, and let's write out to like NFS. Maybe lab work, right? And by the way, we can do mount and maybe grep for NFS, and we can see which of these are read-write. So home is read-write. We should be able to read and write on there. Lab work is also read-write. So let's go to maybe our local system here, root, and let's make sure that maybe dd in file equals dev 0, out file equals big file, block size equals 1024K, and count is equal to 2000. So a 2 gig file. Let's write it here. 2 gig file written at closed turbo. Because we're using a virtual machine, or we're using a virtual node, and he can't handle it when you do. Apparently, I don't know. Surprised that that crashed him. Let's go look over at this box. That shouldn't crash him. Well, apparently we found out how to crash these boxes. There we go. That's how we do it. So let's go on a real box. Go on our Moodle box. And on the Moodle box, we'll just run this and see how long it takes to do a 2 gig file down to disk. So this is an actual disk, and he's getting 2 gig file. He's getting about 2 gigs per second. And maybe just for fun, we do a couple of other big files just to get maybe an average. And yeah, I'd say on average, we're right about 1.9 gigs per second. Get rid of all the big files, get all our space back, right? So we got our gigs back. Now, what if we had, do we have a mount? So we've got an NFS mount out on Ranger data. So let's do that same thing, and let's write a big file, and let's write him out to Ranger data. See how long this takes. So we were getting about 1.9 to our local disk. See how long it takes to get out to our 373 megs. Let's do a few just to get a good average, right? I think that's about what we're going to expect. We're right around 370. Yeah. Let's say 3. We had a slow one. I think that's far enough out that if we did 5, let's do 5 of them. Now, that's 358. Now, we have one that is vastly outside of what our average currently is. We have 2 ways to deal with this. So we could just drop it and say average is about 370, right? Give or take. Or we could do, 20 total and leave that in. And then from that 20, we would do a little thing that you'll learn about if you go study some Six Sigma or if you do some statistics. We'll learn about our standard deviations. And we will say, let's figure out our standard deviations from the mean. And we say that the mean, again, is like, even with that, it's still like 360, let's say. But that is so far away. It's multiple. What's the other thing? The O's. You got standard deviation. Somebody help me out. What's the other thing? Brain's not working. Anyways, it's far enough out that we can toss it. So there's different ways to figure out how we're gonna toss it. We could just, again, with only 5 tests, I'd drop it. But if we wanted to, if let's say we were having a problem, we would test this a few times, and then it's a standard deviation, and there's a term for it though. It's lowercase o. So you got your standard deviations from the mean. Anyways, the point is we would calculate this after like 20 runs as being X amount of standard deviations from the mean, and we'd toss it, right? And you could, so my point is, it depends how far you have to dig into this. If you're doing it for contractual requirements, you're going to dig in hard. If you're just doing it because you're like, the system feels slow, you're going to do, right? This this is how I always tell you guys, like, you do the level of effort that you need, right? Let's go to Ranger data real quick. Let's get rid of big files just to clean up and be nice. Get rid of all those ones so we don't, I mean, that's got 100, but let's not throw a bunch of space in there. Yeah, and well, yeah, if you remember your bell curve, once you're 3 standard deviations away from the mean, you're at the 99.7 percentile outside of it. So we just toss you out because you're no good anymore. You're literally bad data at that point, right? So anyways, can you test the read speed? It would be just the opposite of this, DD in file. How long does it take to read the file? That's how we could have done that. All right, networking topics. So again, we're doing the Socratic Method. If you guys have never heard about the Socratic Method, what it is we're just asking ourselves questions, and then we're just putting it to the test. Like, and again, this isn't to challenge ourselves. It's not to be like, ha, 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 I know 30 commands and you know. No, you just need one good command to do a thing. So we're kind of working through and sharing commands and figuring stuff out. Yeah, so let's go with networking topics a little bit. So I'm going to go back over to this box. Let's hopefully back up. Let's go to 18. Maybe he's back up. I broke them both. All right. We gotta figure. We got some busted servers. Oh gosh, let's go fix our servers, guys. Apparently, some of our boxes are down. So 18. What's wrong with you? Oh, we hit the old out of memory problem. That's what was causing it. Let's force a reboot on 18. Force a reboot on 19. And then we'll do the most logical thing. We'll go to 17. All right. So we got a bunch of networking questions, right? And we've been doing a lot of networking stuff and messing around with a lot of stuff. But let's go look at some of the networking stuff and see kind of what's going on. So the first question is, can you show all the interfaces on a system? You're at a server. You've never been on it before. You've been told that there's some problem with maybe getting to it. You were able to SSH right in, but just because you were able to SSH in, especially from like a jump box, doesn't mean that there's not something else going on in the network. So how would you see all the interfaces on a system? Like, I work on systems that they've got their main management interface, and then some of them have a secondary fast or high speed interface, and then we've got our data backplane, which is sometimes InfiniBand. And you say, really? I thought InfiniBand was your high speed. Yeah, sometimes we have a 1 gig front end to just send commands. We've got a 10 gig provisioning network also on Ethernet. And then we've got like our high speed up to maybe 200 or 300 gigs per second. So, Googly Eyes said show int. I don't know if that one will work. Let's see. We can definitely do IP adder. And let me show you guys one of my favorite ones that I've learned recently. IP-BR ADDR. You do have to do it in that order, and it just shows us a nice little brief one. You've also got ifconfig. Ifconfig will show you some information. That's kind of an older one that's kind of going out, but it's how do you want to see it? Like, what do you want to know about the system? And then we could spend all day here looking at this and going, well, how do we know? And by the way, I think there's a bunch more questions, but we could just sit here, look at real quick and go, well, do I know what the maximum transmission unit is on ETH0? Can I find the MTU, or the maximum transmission unit? And then, do I understand enough networking to understand why I want to know that, right? And can I show you guys something? I haven't brought this up in a while, but I was doing it down in our Discord. Redbook. There's a really good Redbook right here that I'm always telling my Linux engineers about. I'm always telling my Linux guys about this. I'm going to link this to you guys. This is a free book from IBM. Hopefully I didn't just mess that up. I'll link it over to you guys on Twitch. It's a free book, and people ask me, like, how much of this do I need to know to be a good Linux engineer? And I say your Linux systems are always going to touch a network, so you do need to understand networking. Let me just put that out there. But what I think you need to know to at least be proficient out of this book, free book, is probably down to, man, look at all this stuff. There's so many good things in here. But you probably just need to know the first, I want to say it's like 170 pages. Hold on. Pull it up right here. That's like the first 170 before you get to like routing protocols. So 1 to 170. Now, are there all kinds of other chapters in there that are probably good and useful? Sure. By the way, and I didn't get a whole lot of participation in this, but in the networking topics, I had a bunch of these that I wrote where it was like, go in there, read pages 29 to 33 of the book, and then open up Wireshark and get some information, and then do you understand these things from the book? So I have a bunch of these up in the Discord, 20 to 27. I think that's as far back as I go. So I have 1, 2, 3. If you want to get involved in those threads, like nobody even did the last one. It was, I don't think anybody did this. But it was like, read about these, understand these protocols, know how they interact with some of your systems, right? Like, know how this works. And then, we didn't have too much participation, so I stopped doing it. But if people were interested, I would do that more. But maximum transmission unit lets you know how big is the maximum transmission unit of the data frame, so layer 2, that can come down from an IP packet above. And we'll break that here in a little bit, because I think that asks us to break that. Discord link, hold on. Over on the YouTube side, here you go. Oh, you found it? It's also down in the description, yeah. But there it is for people as well. Also, sometimes for some reason, people on YouTube have a hard time using the link. Like, I don't know if it's busted. If you put it in an incognito or any of those browser tabs that are not, there's no other cookies, it'll work. Because for some reason, I mean, that is a link that's set to never I want to say disintegrate, never expire. That's what it is. It never expires. But okay. So can you show all the interfaces of the system? Yes. And then we can see a bunch of information about the system. Pretty good. What other ways could we see? I mean, I see this, but what other ways could I see the interface of the system? Could I do a IFstat? Do I have IFstat on here? There we go. There's some interface statistics of my system, and that tells me that I got to loop back in an Ethernet 0, and it tells me kind of what's going on them. Maybe there's some useful stuff there. Okay. So ifstat, IP adder. I love IP adder, but I also love IP adder with the -br in there for brief. I want it to be a little more brief. Okay. Can you show all the interface on the system? I can. Right. All right. Can you show that an interface is connected physically? This is interesting. This is a virtual machine, guys. This system that I'm connected to for Rocky, this is a virtual machine. He exists inside of this guy right here. He doesn't have an actual network. I can see that it's active here, but what if there was some problem on my machine all the way to my system? Do I register that there is a connection on the Ethernet? How do I see that? Does anybody know how to see that? This is a fun one. This is a fun tool if you've never used it. What's the tool to tell us if the Ethernet is up or down? And it can also tell you negotiation rates on Ethernet. So if you plug in like some of these like SFPs, like these fiber tools, and then your device isn't reading it right, and you're like, well, the drivers are right, and this is right, and that's right, but I'm still not getting a connection. Can I see that the connection's actually up? And by the way, you might say, well, Scott, you could just go walk in the data center and see if the light's on. We used to be able to do that, but this doesn't physically exist. It's only in there. And 2, I'm too lazy to go walk in the data center. Or maybe the data center's in like Richmond, Virginia, and I have to check it from my desk right here. How do I know that that light is on in the back of a system? That's it. We got it. ETH tool. And ETH tool is awesome because it just tells you, a bunch of negotiation stuff for certain links, but it can tell you if the link is detected to your system. This is huge. This one right here, I'm not going to say this like built my career or anything, but this right here has been a quick, people are like, well, hey, are all the systems up? And I'll go, I'll have console to all of them. And 7 of the 10 will have link detected yes, and then 3 of them will not. And I'll be like, hey, these 7 look up. We can get to them via ping and SSH. Let's focus on these last 3. I don't see an Ethernet connection for them. The box is physically up. I see the same modules. I see the same drivers. I don't see any errors, but just the Ethernet's not up. Now look, I'm not blaming network, right? Like I tell you guys, you don't have to get on a call and go effing network. It's at network. No, you can just say, hey guys, I'm not detecting a link on my box on this side. Can we get somebody? Do we have hands in the data center? Does somebody have to drive down there? What's our next step? Because our these three devices do not physically see a link detected. And then if it's a virtual machine, right? One of the things that happens sometimes is when VMs get moved, if somebody manually moves a VM, not like your DRM, that DRM tool is pretty good for checking this stuff, whatever that DRM service is inside of VMware. But if somebody manually moves it, sometimes they don't make sure that the type, like there's these two different types, like very popular types of the network adapters. I think one's called like an EN something, ENSO or something. And sometimes they don't check to make sure that's compatible and they move it. And then your device can't boot up with the network switch inside of the ESXi machine. That's a less common problem now. That was more of a problem like 15, 20 years ago. Not blaming DNS, what kind of sysadmin? Yeah. Well, we got the haiku, right? The little haiku that says it wasn't DNS. It can't be DNS. It was definitely DNS or whatever that haiku is. Also, I'm super happy my wife, like I built my wife's desk. I could drop it up in the Discord for you guys. Hold on. I put my wife's desk together. So she's going to be super happy. Then her laptop's here. And she wanted to move, by the way, guys, I moved into a bigger office in my house. And then she wanted to have a little table to do stuff. So, how's it going, Killa? Yeah, we're just hanging out. Yeah. My office is a mess in the pictures, but it's because it is really nice and AZ, isn't it? All right, hold on. I'll drop these pictures in. I'll drop them in like off topic. Hold on, and I'll pull them up for you guys on chat here. Hold on. Where's off topic at? Can't find it. Oh, it's because I closed it earlier messing around. Off topic, and then I'll just drop the two. Actually, I'll just drop the one picture. The other picture I took to show the wife. But I'm still moving in. I haven't done all my cable management yet. My cable management is next because I just moved into this office. Where's it at? I think it's here. Yeah. So this is her little desk over here. I'm gonna do all my cable management still. Don't worry, guys. That's my fan that dumped off my desk a little while ago. So this is and then she'll be over here, and then I have to do a. She's got a chair coming in. I got to put it together a chair for her, and then she's got a little thing on my rug here, so she can keeps the rug, and then we have a rug on the rug to protect the actual carpet in the room from me rolling around over here all crazy. This monitor, by the way, is on a swivel. So this monitor over here, when I put it on that standoff, so I have like a 4-inch standoff for both of my monitors. This one's on a plate so I can rotate it, and then she can watch it from the, she's got a big beanbag chair in my office here. Actually, now that I think about it, she's taken over more of my office than I have. But I got a lot of room in here, so that's okay. But anyways, that's the wife's shorter desk. I got a bigger desk, and she's got a shorter desk than my laptop here. So this is what I'm sitting on right here, normally. All right, anyways, so we'll get that out of the way. You guys can go play with that. So can we tell that it's the interface is there? Good. Yep. Can we determine the default route? Ooh, how does my system? How do I get out? Rugception, yeah. Yeah, so Alpha Victor Charlie, when we moved in here back in 2020, right at the start of COVID, we moved in this house. We went and bought rugs from Walmart, and we put them down where I was going to be like rolling around a lot. And then also I put like the little plastic rug protector on it too. So then theoretically, when I pull that up and I pull the rug and the rug is just trash, the rug in this room was garbage. Actually, garbage. It's this rug now for Ranger. Poor Ranger. He got a hand-me-down rug, but he loves it. Anyways, so then I don't wear down the carpet, right, by rolling around and being all crazy. Are there any good VMs that you should check out hosting on Proxmox? Killa, it depends what you want to do, but I can tell you, if you have, you should look at, well, I mean, it depends how much you want to do networking as well. Like some people, by the way, we're doing networking right now in the lab, but we're a Linux group, but we also, a lot of us do networking, we do security, and we do all these other things. You can't just be a pure Linux engineer if you're going to be You got to understand the network and how you interact with it and stuff like that, right? Well, anyways, where I'm going with that is look up GNS3. You can run GNS3 live on one of your servers, and then you can connect in, and you might say, oh, why would Scott ever recommend VNC or something like that? You actually can just connect right in and run right off of your GNS3, and then you can have full environments inside of one of your machines out there, Killa. In fact, with because I have that guacamole server, I was going to eventually give people access to jump into the GNS3 servers and do like labs and stuff. Oh, you got full lab stuff? Well, then you don't need any of that. Ignore that recommendation. That was just me saying a way to do it. But yeah, let's go look. So can we determine, how do we know, our system has these addresses, but how does my system know where it's going to send something? By the way, IP tables and NF tables and all of the stuff that happens in the kernel with routing, all of these things are the same type of stuff that Cisco devices do, right, under the hood. But how about IP route or IPR? And what are the routes that my system knows? Well, if you're in, here's my system's network, 192.168.200.67/24. And if you don't know the significance of the /24, let me simplify it for you. The /24 tells us where the network bits end, and then the last bits remaining out of 32 total bits are the host bits. So in this network, the 192.168.200 represent the first 24 bits. They are the network portion of this network. So if I were to say the network is 192.168.200.0, that would be accurate. You can't use the network address as a host. So that one, thrown out. The last address, which is 192.168.200.255, that's the highest number you can represent in this network. That's the broadcast address. Can't use that either. You'll see your systems using it all the time, but you can't assign a host to it. So there are 254 hosts available, addressable in this space. We're only using a few of them. And when my system wants to send to one of those addresses, 192.168.200, it uses ETH0. That's how it gets there. Uses ETH0, sends it to the network, everything's good. Now, if my system doesn't know where to send something, if it's not in 192.168.200 dot something, means it's anywhere else in the world, it sends it to the default address, also via ETH0. But the thought process is it compares all the way until it gets to the default, and then it launches out the default. So my system always sends to the ETH0. If my system had more networks, which I deal with systems at work that have 6 to 8 networks sometimes, and you need to know where they're going to send your packets, right? Because that's a important thing for troubleshooting how something's moving. Let's see, IP route list. There you go. How about there's one, somebody showed me, there's route. Route will show you that as well in a little bit different way. That's kind of cool. ARP will show you useful things. It'll show you a gateway, but it would also show me all the other devices if I was talking to other devices. So while that will tell me that that is the gateway, I guess, yeah, well, I guess that is the default route. So I guess we could accept that. Yeah, that's a good answer. So IP route, IPR, IP route list, they're all shorthand for the same IP route list. Route by itself, and then ARP-A will accept because it does say the gateway there. These are ways that we can find. Uh-oh, Julie the wifey's calling. Hold on real quick. Let's see what the wifey says. Hello, wifey. I am streaming. What's up?
I was just going to see if you wanted me to maybe get a wrap and salad though.
Yeah, we could do that.
I'm going to eat when we go to that little thing tonight for with my beauty school friends. But I'll
Okay.
see you with chicken barbecue ranch.
Okay, loves you.
Bye.
Bye. All right, she's bringing me food. She's bringing me a. There's a little place out here called Salad and Go. She's gonna bring me a little wrap. Look at Ranger down there. Look at that dog. That dog. He is. Some of you guys know he's the laziest guard dog that's ever lived. Oh, I should have told her laptop's in. Hold on. I'll call her back on stream here real quick. Let's turn it on real quick.
Hey, what's up?
Hey, you're on with stream right now, so the stream can hear you. Hey, your laptop came in,
Yay!
and I got your desk set up.
I'm very excited.
Okay, you gonna be around? Yeah, we'll do it later.
Yep, I'm gonna grab food and then I'll be home for like an hour.
All right, loves you. Bye.
Love you too, bye.
All right, good. So she found out when you guys did that she got her laptop, so she can start setting that up. That'll be good. Then, yeah, can we determine our default route? Yes, we know how to do that. Can you ping the default gateway 3 times? Do you know how to ping something? Do you know how to ping it only 3 times? And do you know how to target the default gateway? Well, we know what the default route is, so we know the gateway. How would we ping that only 3 times? We could do... But how do we do it only 3 times? There you go, -C3. Otherwise, how long does Linux ping for? Forever, right? Till the end of time. So, ping will not ever stop if you don't tell it to. All right. Can you determine the MTU of the network with ping? Can you determine the maximum transmission unit of the network with ping? I know you can do it with this. I know you can do IP adder, and there's the maximum transmission unit right there of ETH0. But can you use ping to determine it? Do you guys know how to do that? Yeah, crash systems. Yeah, I used to say until all time ends or until the server shuts off. Yeah, ping will just go forever. I actually did have one pinging in one of these other windows. I think I cleaned it up though. Yeah, it's gone now. So, check this out. We know it's 1500, but can we prove it's 1500? And some of you guys have seen this before. This is a fun command. Let's ping -C1, so we only try 1. And let's say the size of the traffic that we want is 1500. And then we're going to ping over to 192.168.200.1. And that'll ping just fine. But that pinged at the maximum transmission unit because something happened that you couldn't see, and I'm going to show you it real quick. Right here, we're going to say, -M, capital M, do. So we're going to set, so that's M is the permutation, and we are going to set the do not fragment. So do set the do not fragment bit. I know, it's wild, right? Watch this. Now, it's too long. So could I walk that back to like 14, maybe, I think it's like 68 that'll work. That worked. Could I go up to like 1476? That was too long. How about 1474? That's too long. I think it's like 1472 maybe. That worked. So, as the packet was coming down the stack, right? As the packet was coming down the stack of the OSI model, and the packet was trying to go down into a 1500 unit frame. So the frame is 1500 bytes long. We were trying to send one that was 1500. That was too big, and we said, and you cannot cut it. This is fragile, right? This is a major award. We can't. If you guys don't know what a major award is, anyways, we can't cut it. Don't cut it. So it doesn't fit. So it just gets tossed. That's what happened there. If I make it bigger again, watch. I'll make it like 1600. But I'll take away this. It'll work just fine because behind the scenes, without you seeing, it split it into 2 different 1500 MTU frames and sent them both. And then you got the one back and it put it back together. That happened seamlessly. I come back here. I turn that on. Doesn't work anymore. It's broken. It's actually not broken. It's exactly working like it's supposed to. And some of you are going to say, why do I... some of you are going to say, why would I want to know that? Well, here, what if... This is something I've used in my career before. I've been told I had jumbo frames Jumbo frames are typically 9,000 or bigger frames in the system, and we almost always need them set to talk to a storage area network, right? So I'll tell them. Well, I gotta tell somebody 10 a.m. Shoot, give me a second here, guys. All right. Okay. Good. So, what was that? Where was that? Broke stuff. Oh, yeah. Anyways, my networking team, because I didn't control the network in this environment, they assured me that I had jumbo frames the entirety of my path between my device and my storage network, right? So one of my interfaces, again, I only have 2 interfaces on these boxes, and one doesn't really exist, it's just a loopback. I had a specific set of interfaces that sent data on this path to my storage. And the guys assured me, they were very confident that I had jumbo frames set the entirety of the way. So I did this. I did something like this, where basically I walked up, right? I did a 4i in sequence, and I started at like 1350, and I went to like 1500. I think I even jumped up to like 1600, right? So, and I'm gonna step by like 250. So every 250, right? Whatever. And then I'm gonna say do, and I'm gonna ping -m, and I'm gonna set my settings here of my size to I, right? And then also with this, yeah, that'll work. So do that, and then done. Maybe even sleep 1 done, so it doesn't go too fast. Whoops. Oh, ping might not like that. Fuck it. Take the sleep out. Who cares? Oh gosh, guys, you gotta stop me. You gotta stop me. All right, sleep 1 still. All right. So now it does the first one, and then immediately it's too big. So maybe I need to make that a little smaller. So maybe like 50, right? So you'd see that one, that one, that one, that one failed. And if that's too hard to read, you might do something like this, and then you would say do echo I am checking $I size, right? And then ping it. So now I am checking 1450 size, and then we see where we started to fail. Maybe I even put like a, we could do, that's fine. Maybe we do something like this, because then it's even more obvious, right? So I'm checking the size, it's good, failed. Right, anyway, so I did that and I proved, and they were like, oh shoot, one of the switches in there. I forgot that it sometimes takes that path and whatever. Then we fixed it. Didn't have to point fingers, didn't have to blame network. I just said, guys, here are my data. Here's what I can prove. My path does not have the ability to go over 1500 MTU. I don't know where it is. That's not my job. I don't know that. I just know between here and there, I can't send something greater than 1500 maximum transmission unit. Does that make sense to you guys? Because these, when you do the jumbo frames, you want to be able to fit it all in there. Yeah, the only thing that network guys agree on is that PCAP doesn't lie. Fair enough. So this is a way that, again, I wasn't even trying. I had a good relationship with these guys. In fact, I did networking when I needed to, but this wasn't my set of systems that were under my control. So, yeah. So this is kind of how we can do some of that stuff. So can we determine the MTU of the network with ping? Yes, we can prove it too. So there you go. So Mr. Couture, I want to prove that so there's with big data like storage area networking, you want to send as much as you can with as small a header on the front. Think of it like bigger and bigger shipping containers, because there's less overhead and more data being sent. That's why we don't want to split up our data. And I was trying to get the data, the speeds of this SAN network that I was dealing with worked best with the devices if you were getting 9,000 or bigger maximum transmission units. Fair enough. All right, guys, I do have to get off of here soon. Can you properly identify all of your IPv4 and IPv6 networks? Yeah, this IPBR80DR, this will show us that this is a dual honed network. It's IPv4 and IPv6, and this is a dual honed network of IPv4 and IPv6. However, and I've shown you guys this before, there is a limitation. I'm only forwarding IPv4 frames out of there. All right. So this is, yeah, we can see these, but I don't allow this to traverse the C router. So this really is truly only an IPv4 honed network as far as that goes. All right. Can you list your open ports? SS-NTULP will show you what your system's listing on. It will show you where there are paths to enter your system, and then the strength or hardening of those ports has to be determined by whatever application or software you're running. All right, guys. So here's what I'm going to do. I have to go because the wife's coming home and she's bringing me food. So we will keep working on this stuff. I have fun with the Socratic method. I think some of you guys do as well. Obviously, we can mess around a little bit and stuff, but also we can pick up new stuff that's valuable and good for us to learn about. I will, on the Twitch side of things, I'm going to go find somebody to raid. Let's see who's doing stuff out there in the world. We'll go raid Sid because I like hearing him yell raid at us. For you guys that are around, I will be around some this weekend. Obviously, on Saturday we have a really big thing on Saturday, right? Doing our Linux groups and stuff. So, all right, I will talk to you guys later. Take care.